Okay, so few note point I want to mention here before moving on to some examples. The ID value, if ID is mu n cox w divided by 2l vgs minus vt whole square, I want to discuss about this parameter. So mu n cox is something called constant k n dash. Okay, k n dash. These all quantities will be given to you mostly, where mu n is the mobility of electrons, n is their mobility of electrons, cox is the capacitance, which is defined as tox divided by epsilon ox. Ox means oxide. So you remember there is an oxide layer between gate and channel. So that oxide layer we are talking about. So capacitance of that layer, oxide layer, is TOX divided by epsilon OX. Okay, epsilon is the permittivity, okay, which can be written as epsilon R epsilon naught. Epsilon naught is constant, whose value is 8.85 into 10 power minus 12 farad per meter. Okay, this is just a constant, and epsilon R will be given to you, which is the material which is used to make oxide. That dielectric constant will be given to you. Then TOX is the thickness of the oxide layer. Okay, so you can think of it as a capacitance between gate and channel. This is called as capacitor, oxide capacitance. Okay, COX, that is K n dash. And this whole quantity mu and COX W divided by L, sometimes it is given whole of them will be called as process parameters, which is represented by Kn. This is Kn dash, this is Kn process parameter, and all the quantities will be given to you. Okay, this is the arrangement to show you the oxide layer. Then sometimes Kn is also written as ID on divided by VGS on minus VGS cutoff whole square. Okay, all the quantities will be given to you. It is a constant which is used to solve the current equation. Hence, that's the reason I wanted to mention it. It is not dependent upon type of the MOSFET, N type or P type. Only the N type or P type mu mobility will change. That's it. Nothing else will change. Okay. So this is one constant I wanted to talk about. Second, I will show you some of the representations quietly used, commonly used for MOSFET. Okay, so let's look at how people represent JFET, depletion MOSFET and enhancement MOSFET. These are the representation, different representation: N-type, P-type, N-type, P-type, N-type, P-type, N-type, P-type, N-type, P-type, N-type, P-type. Okay, so here you can see the JFETs. The direction of arrow, gate arrow is going inside. Gate arrow is coming outside in P-type. Drain, gate source. Drain, gate source. Okay, here the same representation. Sometimes this line will be not in center, sometimes it is downward. So this is how people represent in downward direction. So it is going inside, arrow is same. N type, arrow is coming out. So P type, N channel, P channel, N channel, P channel. Okay, so this is how you see the representation of JFETs usually. Then comes deep MOSFET. Okay, depletion type MOSFETs. So depletion type MOSFETs will be represented in this manner. So gate, drain, source is there. There is one more terminal and arrow is going inside. So this is N type, N channel depletion MOSFET. This extra terminal is called body terminal, which is connected to source only. Okay, so that body terminal's importance will come when we will see channel length modulation. There it will come. Okay, right now we don't have any uses of that, so it will be directly connected to the source terminal. Okay, the arrow is going inside, it is N type. Arrow is coming out means P type. Or you can represent in this fashion, where you don't represent the fourth terminal, but the direction is changed. You can see the arrow is changed. Arrow is now from gate to source here, where here it was source to gate. Okay, so you don't represent. This is the most common one. Okay, most common one in depletion type. So source, gate to source arrow is going, it is N type, N channel. And from, if source to gate it will come, it is P channel. Here in P channel it is coming from gate to source. So just make sure that you don't get confused. Then comes enhancement type MOSFET, which is similar to depletion type MOSFET, just you are representing this line with dashed line. Okay, so dashed line, fourth terminal, current arrow is going inside, N type. Arrow is coming out means P type. Okay, and you remove the fourth terminal and change the direction of arrow. This will be the arrow direction. Okay, gate to source. Okay, gate to source. This is drain, this is source, it is drain, this is source. Source to gate it is going, P type, N type, gate to source is it is going. And these are dashed lines. Okay, that is how you represent enhancement type MOSFET. Okay, so mostly we will be using these kind of MOSFETs. Okay, the three terminal types. If enhancement, then dashed line. If not enhancement, means solid lines. Okay, so this is the representations, different representation. And so yeah, I think this should give you a clear picture of how we will represent in future videos. You might have seen some of the examples in fact section, but this time I will try to be elaborate as I can, so that you will get a clear picture about P type as well as N type MOSFETs. And I mean, with respect to graphically, whatever we have learned, drain characteristics and transfer characteristics, with respect to that we will solve the questions. Okay.